Okay, so we can start and we can first have a look at the schedule. Okay, for this week. Today we are here, Monday. Today we are going to talk about React, so starting the last very important topic of this course. It will take us to the end of the course, mostly to the end of the course. And tomorrow there will be a lab with my colleague Antonio in the room. Lab number 7 is already online. Okay, it's just applying what we are going to see today. Okay, just getting started with React, very simple. And then we have Thursday, as usual, lecture in the room. And as soon as possible, I will publish the schedule for next week as well. Okay? So, so today we are going to talk about React and why and so on. That's what I'm going to introduce to you in a minute. Okay? So, in this course, we had to make a choice at a certain point. Either we develop an entire web application from scratch, just with JavaScript, right? So just programming in JavaScript. As you start from scratch when you program in C, in Python, and so on. Nowadays, you can start from using AI. That's true, but I mean, but you saw in the labs and last labs, and also we saw during the lectures, how much complex it can be to develop directly in JavaScript, right? So just to remind you, you remember the example that we saw, not about process scripting, but yeah, browser forms, events, and so on. You remember how complex it was, the part that was devoted to JavaScript. You remember the size of the file? And this was just to create a table, right? I mean, so much code just to create a table. And I bet if you come back to this code in a few months without comments, I mean, it's a bit difficult to understand what it's doing, right? That's the usual stuff we have in programming. Okay, nowadays maybe AI can help us, that's true, but so this is the reason why we would like to start not from scratch, but using something that helps us in developing clean and understandable web applications. Okay? And nowadays there are a few frameworks that can help us. Frameworks in this context basically means JavaScript libraries that basically we can import them and load them at start time when you open a web application. And we chose React. Why? Because it's probably one of the most popular, if not the most popular one used nowadays in web applications. Okay? It's well maintained, it's been evolved quickly, and we believe in a good way by a major company in the field that is Meta, the former Facebook. And this is not the only library, but that's the library we ask you to use for the exam, okay? Because we cannot learn all the libraries, that's one point, but also because we need to actually understand the principles that are behind developing a single page application. Everything is handled by JavaScript, and how do we handle events, how do we handle refresh of the content, and so on. And of course, we will reference a lot what React think is the correct way to manage these things, but I mean, we would like to understand also the problems and the issues involved in this, this way of thinking the web applications, okay? So, there's a lot of documentation around. You can find the source code as well, okay, on Facebook/React. I mean, I'm not asking you to read the source code, of course, because we need to understand the principles and then use the library in the most effective way as we can. So a library is needed because we need to simplify the browser environment. You remember we have a lot of API calls available, especially in the DOM. Create a node, destroy a node, append child, put it as a sibling, hide things, we can change the appearance through the style and so on, okay? So we need something which is a bit higher level, And if we can define components that are a group of HTML tags, that would be wonderful as well. Like we do, we create functions when we program with simple statements and so on. And this is what we can achieve with a library or a framework like React. Okay? Also, handling events is very important for a web application because everything will happen as an event. Okay? Either user-initiated, click on interaction in the page, or by some asynchronous events like data arriving from the server because we requested some new data and so on. Okay, of course, when we use a library, we need to fit into the logic that the library defined for us. Okay, so the library exposes a certain number of functions we can call them primitives in general, but I mean, actually in the JavaScript, they are functions that we need to use. And these functions have a meaning and a number of parameters that can take, a return value, and so on. Okay? And so we need to understand the programming pattern that is consistent with the library that we chose, that is in this case is React. Okay? There are a lot of compatible plugins and extensions and so on, and this is good in general. And for instance, we chose Bootstrap as a styling framework a few lectures ago, because there is also the React version of Bootstrap already ready with many components, many items ready to use in React applications. Okay, so this is an example of important extensions or libraries which are fully compatible with React. And also we have some limitations because the state management of the application is quite rigid in React. We need to really follow strictly the rules that React gives us about managing the state. But we will come back to what is an application state many times during the next lectures, today and the next lectures especially. Okay, many resources available. React.dev, okay. Basically you find a lot of things there. Tutorials, guides, guidelines as well. Okay, so recommended practices as well. And API references. So what does a function take as a parameter, what's the meaning, what's the return value, and so on. Okay? There are also browser development tools available for React. It means that we already saw the window here for browser development. That is the standard window, but we have extension that can be installed to manage React applications in development mode. So basically to inspect the props and states which are and components which are the basic building blocks of React. Okay, I think I already installed it. No, this is for Chrome, right? So I don't want to switch to Chrome. No, thanks. I wanted to click on the one for Firefox because I wanted Firefox. Anyway, it's very simple. I think, yeah, it's already installed. Basically, it's here in the extensions, okay, React Developer Tools. And it means that when you open a React application, there will be a tab here. Later on, we will see it. That allows us, like here, components, to inspect values in React and so on. So I invite you to use it. Either in Firefox or in Chrome. I would avoid other browsers because I'm not sure the extension has been developed, and also maybe it's a bit more difficult to manage. Okay, so please stick to these two browsers, which are the most used ones, by the way. I know there is Safari for Mac and so on. I have a Mac as well, but I mean, I try not to develop there because it's, you know, this extension, for instance, I'm not sure if it works or not. Okay. I mean, the extension is not fundamental as any debugger you can do without it. But if you have it, it's nice because sometimes it's hard to debug things, right? So let's start having a look at the design principles. So what's the idea behind React that has been used by the React developers to help us in developing web applications? So key concept. It has a declarative approach, okay? You will never use or write functions to explicitly manipulate the DOM tree. So no append child, create node, remove node, or whatever name it is, okay? You declare what you want to see, okay? And we will see basically declaring means writing a few snippets of HTML code, okay? Maybe there are no HTML tags, but there are HTML components, which are functions defined by React that can render tags and so on, as we will see in a few minutes. But you will never manipulate the DOM directly. If you do it, I mean, it's really a problem at the exam, okay? And you shouldn't do it, because React is in charge of doing this, and you are interfering with React, okay? Never explicitly define the order of operation again. That's the same point, because React is taking care of manipulating the DOM, so updating the view and managing the events as well. So we need just define how each component is going to render itself. So we create a new component, like the table with the list of answers, as we will do in the second part of the lecture. And we write some code, and we just say what we would like to see. And React is in charge of manipulating the DOM, updating the DOM, interact with the browser, and so on, to create what we want. Okay? So we declare it like a table, a row, and so on, and React will do the rest for us. It has a functional design approach. That means basically we create new elements like the HTML tags, which are named components in React, by means of functions. So we write a new function every time we want to write a new component. Okay? A component is a generic piece of HTML code, let's say, that you can insert in your application. And React is in charge of doing the rest. So everything is re-rendered every time something changes, and we will see how to manage the state later during the week with React. Okay. So a state means, for instance, the data contained inside the web application, or some presentation state like a window open or close, box open or closed, a checkbox set or not, and so on. Okay, just to give you an idea what a state is, but we will come back to this. So React adopt this very functional approach. It means that what you are going to see can be computed through a function that we are going to write, or it's already written by React. It is a function only of a set of, we call them properties or props in React. Props is the jargon for properties in React. It's basically an object that contains many keys that we will define as we like. And on the basis of the keys, the values of the keys that we pass as props, this function will return something to be rendered by React. Okay? This function should be idempotent and immutable. Idempotent means we pass the same parameters, same props, the result is the same. Okay? This is fundamental for React because so it knows when it needs to call the function again or not to change the user interface. If the props did not change, there's no need to call again the function. Okay? Because the result is the same, because the function must be idempotent. And immutable in the sense that once you define it, that's all. Okay, you don't change it. You don't change it at runtime. You can change it when you are developing, of course, but you restart the application and so on. More complex components have a result, so a part of the user interface, which is also a function of the state in which it is. The state that is contained in the web application, like I told you before, the data that the application has and so on, but this is a topic for later. So React exploits this immutability of objects to simplify the programming and efficiency of processing what we write in JavaScript to render the user interface. Okay? Also, props are immutable in the sense that inside the function that we saw before, this f, you cannot modify props. I mean, JavaScript doesn't prevent you from doing whatever you want, but this is a programming pattern in React. I mean, there's no point in changing the value of props because React will not care about this changed values of props. Okay, so it expects these props are just passed to the function, and so there is no need to change them. And about the state, well, we come back to the state. Okay, we need to use functions, special functions provided by React to modify it. So functions are pure functions, must be pure function in the sense that they should have no side effects besides computing the return value. And that's how you achieve the idempotency, okay? So it means you call the function again, there are no hidden values stored somewhere or values taken outside the function to compute the result. Otherwise, this property that you call the function and you always get the same fragment of user interface when you give the same props is broken, okay? Good, so they are predictable in a certain sense, okay. Applications in React are made of components, okay? And in theory, in practice, it's a bit more efficient, but at least in theory, the idea of React is that every time something changes, the application re-renders itself, so it reconstructs the user interface from scratch. It redraws the whole user interface. That's the idea. Then in practice, there are a few optimizations that the React library does. Basically, since the function you saw before can be a function of a state of a props, basically React tracks the change of props and state, and it decides what parts of the user interface needs to be re-rendered, and then it applies these changes, okay? So in theory, it's like every time we want to render the user interface because something has changed, we could call again all the function, get the results, and redraw the whole user interface, which is basically, if you remember what we did in the last lecture when we programmed in JavaScript and we did, you remember, vote +1 with the button, and we say, what do we want to do? I mean, do you want to update the content of the data structure? Yes, of course, because the data structure contains what will be the state in React. But then, how can we align the state with the user interface? And that's the problem, right? That's the problem that React solves. In that code last week, I mean, before Easter, we solved it basically destroying everything and recreating everything from scratch. That is basically the idea of React, and that's why also we did that thing as well. But of course, this comes with some performance issues, right? Because if this application is small, nowadays computers are fast, smartphones are fast, and so you can destroy everything and redraw everything, and basically you don't even see that something has happened in the user interface in the sense that it doesn't disappear and reappear again because it's so fast. But when the application becomes more complex, that can be a problem. So how can React solve this problem? Okay. Well, React implements what is called the virtual DOM. Okay, you remember the DOM is the tree with all the HTML elements. Okay, and that is constructed by the browser and maintained by the browser. And depending on how the virtual DOM is, the browser renders one part of the other in the window. Okay, if you add the form renders, and so on. If you remove the form disappears, etc. Okay? And so the idea of React is that it has another structure that basically mirrors this DOM that is inside the browser, and it is called virtual DOM, and it's just an internal in-memory data structure, optimized, very fast to update, and so on, completely maintained by the React library. Okay, that's what the React library does, in short. And also it allows us to correct and fix some DOM anomalies and asymmetries, because the DOM evolved over time, over 30 years, so something could have been done differently to make it a bit more intuitive, a bit more easier to use. Also for events, it manages its own events and so on. And the point is that since modification to the DOM tree, the one of the browser, are expensive, because every time you change something in the DOM, the browser has to recompute the layout and to update the user interface. Basically, React first computes, you apply the modification to this virtual DOM, React computes the difference between the old virtual DOM and the current virtual DOM, and it applies only the differences in the actual DOM of the browser, okay? But this is done completely automatically. We just have to follow the React pattern to make sure that everything happens in the correct way, okay? So only modification and differences are selectively applied to the browser's DOM in batch by React automatically. We don't have to do anything about this. Just to ask for modifications in the virtual DOM, but we don't append or create nodes and so on. We have a declarative approach that we will see in a minute. So basically, we have these functions that decide what to render. Okay, so before going into these functions and see an example, so that's how it works. Okay, so we need to change something, and basically, through these functions with the React, something should change in the user interface. And so React creates a new virtual DOM tree. It computes the difference with the old one, computes the minimal set of changes, so what has to change in the actual DOM, put them in a queue, and at a certain point, it applies the changes in the browser. Okay, so let's say the red element has changed, something needs to change, and the browser, at a certain point, React applies these changes to the browser, okay, in batch. It means all together when it's ready to do it, okay, just for efficiency, okay. So in short, every time we want something to be rendered, okay, we change something in the return value of the functions that define the components, and React will apply them as soon as possible. That's the translation of all this discussion. Okay. Okay, React has its own events, which are mostly mapped on the events that we already know about the DOM. So there are event handlers for click, double click, the submission of the form, and so on. These are the most important events that we are going to use. But all the DOM events are mapped on these synthetic events on React. So basically, React is kept in the loop when you change something and something has to change and something has happened in the browser. When the user has interacted with the browser through some events, or some events happened because of asynchronous events, like communication from the server and so on. Okay? Okay, but we will come back to the events later. So this is basic React code. Actually, it's code that we'll never write, but we will see only once here in the slides. So in short, you need to create a root of this virtual DOM. At a certain point, you need to tell React to render something inside, and you will see that we can use this syntax that is basically like writing HTML code. And this root is attached somewhere in our document. You remember the get element by ID. Okay, so basically this is attached at the body level in the root of the body. Okay, so everything is managed by React. But this is done automatically by React. Okay, just to give you an idea of how React works in practice. Okay. Of course, if we have to write something like this without this syntax, the React element syntax here, it would be very difficult because, you know, we are back to create node, append child, and so on. We are just doing it in the virtual DOM instead of the directly in HTML and so on. And so in React, they invented this JSX that allows us to write code like if it was HTML. Okay, you see here root render and less than sign div and so on. This looks like HTML, right? And there is a mechanism to do automatic translation, which is called transpiling here, into calls to the React function that creates the corresponding components of React and corresponding content, attributes, and so on. Okay? So React DOM div, all the default HTML elements have a corresponding component already defined in React. Okay? So div contains an attribute ID with a value test and children, okay, that are H1, P, and so on. Okay? But this happens automatically. I mean, we will always write the syntax on the left because it's much easier to handle, right? Okay. Just a few words about the components and so on, and then we will see an example. So we start to create our first React application. Okay. Everything on a page is a component. Even simple HTML tags are components. We saw them before. The div is a component. H1 is a component. P is a component. So everything which is already defined in HTML is already defined in React. But in addition to that, we can define our components as well. Okay? Components, of course, may be nested as HTML tags. Okay, the render call builds a component and attaches it to the container and so on, but we will never use it explicitly. So, how do we define custom components? So, in short, how can we put together some HTML tags and render them in React? Well, actually, it's very simple. We just define a function, okay? So this takes no parameters, but it will take props in the end, okay? And we just return the content, the way, the content of the component, so the way in which the component should render, okay? Expressed using this JSX syntax, okay? So instead of writing all this stuff, okay, which would be very annoying, boring, and I would say useless. Okay? And you can also receive props. We say the components might receive props. In general, they receive props. And if you receive props, you can use them in determining the user interface, the user fragment that is returned by the component. So like here, props.content, so there is a key content inside the props object, and you can use it as typically a string, okay? Or if it's a number, the number is converted into a string because HTML only supports strings, right? It can be an array and so on, and we will come back to the arrays later. There are actually two types of components, presentational components, which are the simplest ones, and so today we are just using and defining presentational components. Basically, they don't have to manage the application state, which is a bit difficult for next lecture, left for next lecture. They might have some internal state, but again, leave it for next lecture. And so basically, presentation components receive data from props and decide how to render this data that is received from props. If there are no props, it means that the component is fixed and always renders the same fragment of user interface. Or there are container components that can contain a state, and maybe they don't render anything except additional components and so on, but we will see them later. Okay, so props, where do props come from? Props come from the root of the tree of the virtual DOM. So they come from the parent, okay? The parent components. So it means that at the root of the component, either React pass props to us or there are no props, okay? Typically, there are no props because we will use state to contain data, but I mean, for later. But let's assume we are at a certain point inside the DOM tree, actually the virtual DOM tree, and we have a component, it receives props, and these props are passed by the component that is around this one. So the component in which the current one is nested in, okay? Anything can be passed as props. Props are props are JavaScript objects, okay? So they have attributes, keys, and values. Values can be any valid JavaScript value. So it can be a string, a number, or it can be an array, another object, or a function. Even a function. We will pass functions as props as well, okay? Of course, I mean, functions cannot be rendered and they will have to be called, okay, at a certain point. But, I mean, in general, we can pass functions as well. They are callbacks, okay, because, of course, we pass functions because we want to call them later on. So that's the mechanism, okay? Okay, the state instead is not props, it's local to a component. Okay, we will come back to this, so you will not see state passed from one component to the other. Okay, but the important thing is that the state is just a value, a JavaScript value. It can be an object, an array, whatever you want. And since it's a value, it can be passed as props to children components. You cannot pass them, you cannot pass these values up to the parent components because there are no arrow that goes up, right? You call functions. So there's no way to return props, okay? React doesn't allow you to return props. It doesn't make sense in React. But the return value of the function in React, the component function in React, is the UE fragment, the user interface fragment, okay? But I mean, we don't really need to return props, okay? If we need to modify something in the parent component, we will use other systems, okay? So we can say, in short, that React works in this way, with this unidirectional data flow. State or something, some values are passed to the view and to the child components, children components. There is something rendered, some events happen, so some actions are triggered inside the view, typically by the user. Actions change something, typically the state, and this state is passed as props to other components, and these components are re-rendered by React by updating the virtual DOM, computing the difference, and then applying it to the actual DOM. Okay? So basically, the life of our web application with React is a circle where at a certain point somebody, typically the user, does actions. This triggers a series of other actions, an event that is captured by an event handler that changes something, typically a state, that changes props, that tells React to re-render something. And the user interface is updated. And then we are back to the first square. Okay, a state is always owned by one component. I mean, I would leave this discussion about the state for later, okay? We will see just a very simple state today in an example just to, practice a little bit. I mean, see something a little bit more interesting than just passing prop. That means it's like defining static values inside the code and just changing values and see the code changes. But, I mean, this discussion is for later, I would say. So let's try to create the first React application, okay? So we need to import the React library. We want to use the JSX, so we need to have this transpiler and so on. Babel is a library that can implement this translation and so on. We need a web server as well, because we need to serve the application from an actual web server, because in this way we can import modules and so on, use the import in JavaScript code and so on. Okay. And there is another issue for later when you have another web server and so on. Okay? And also for local files, we cannot load the local files directly. Okay? So actually we need a test web server. Okay? And so how do we meet all these basic requirements to start using React? Well, we use a library, okay, this Vite, that is basically a library package, a script, call it as you like, that allows us to create a React development environment for an application in a very simple way, okay? So we just run this command, npm create Vite at latest. That's the name of the package with the version, and latest is just the latest version. Name of the application. It creates a directory with some files and so on. So we'll try to do this now. Okay? So I stopped to be boring. I mean, more boring than usual, I would say. And I use the Visual Studio Code as usual. I mean, I recommend that you create a new folder each time you want to create a new application, a new React application, okay? Because there are a lot of things inside this folder that helps in developing application with React. And so if you want to work on the same application, of course, you modify content in the folder. But if you want a new application, create a new folder, okay? It's like you create a new project when you develop a new program in a development environment like Visual Studio Code, okay? So week 07, we go here, week 07. So there are already examples for later, for today and for next week, next lecture. And so we run that command, npm create Vite at latest my app. Okay? So exactly this command. Okay? And it will download the script. I think here it's already downloaded. No, not yet. Okay. So basically, it installs this script that comes with the package and basically help us in creating this application. Okay. Then it provides us to some choices because it's a generic script and can create a project for different systems and so on. Okay. This is just a choice we made for the course. In the past, we used another system. I think the script was create a React app, but then it became so big, so complex that we decided to find something that's a more lightweight and more intuitive, hopefully. So a framework, we would like to use React. So you choose with the arrows, React, enter, and we choose JavaScript. Okay, JavaScript, enter. Install with npm and start. Now I would say no, you can do yes, and it does the next steps that we are going to do manually just to show you what's happening. Okay, but I mean, when you do it yourself, just run the commands that we are going to run in a minute. Okay, so you see a new folder, my app has appeared, and there are some files inside, and in particular there is an app.jsx file that contains a very basic React application, okay? Always the same React application, okay? It's a test React application. It's a demo, okay? So, cd my app, okay? Yes. And then, you see there is a package JSON, right? So, you know that we are using some packages, okay? React and React DOM, already introduced by this script. Of course, we need to download the React library, which is supplied as a package, okay, by the npm repository, okay? So we do npm install with the network connection. Well, actually, we also needed the network connection from Vite because we had to download it. Once it's downloaded, it goes into a cache, it's local, okay? It takes a while. Okay, it added 151 packages in the node modules folder as usual, okay? So many, we know. I mean, React is quite heavy. I mean, but most of the frameworks are quite heavy because they do a lot of things. I mean, you can question this, but they should be 86 megabytes, I think. I mean, I just tested last week, but I'm not sure. What is node modules? No, the whole directory. 89, well, more or less. Okay, 89 megabytes. Okay. I mean, just for telling you, okay, so you need a little bit of space, okay? But please use a different folder for each different web application because it has a different set of dependencies, okay? So there is a package.json, that means it needs to manage the node modules folder and so on, okay? Okay, but nowadays 89 megabytes are fine, right? I would say. And then npm run dev. We need to run the web server to test our web application. npm run dev. Okay? So white started and so on. You should access the HTTP localhost 5173. The default web server is configured to use this, the first port, which is free, I mean, from 5173. And just for localhost, so you cannot just publish it on the internet, okay? Just published on your computer, inside your computer. So, localhost 5173, and that's the demo application of React, okay? It's different from the one that we saw last year. They updated Vite a little bit, okay? Maybe it's a bit less boring, hopefully, okay? I mean, this is just some icons, some text and so on, links to websites and so on. But there is something interesting. There is a button already working, okay, this count, which updates some state and so on. So there is already something that you can look at. And just to show you, you see this is a React application, so you already have this extension installed. And I can have a look at the components, okay? Actually, there is just one component which is named app, which has props, okay? Actually, no props, I think. Yes, no props and one state, okay? Which is actually the number here, okay? And you see that it's something that might be useful for debugging React application. I mean, it works only in development mode, of course, okay? As all debugging tools. Okay, so let's go back and see what did the create Vite script did. Okay, do, sorry. And so it creates this folder, of course, the node modules, but node modules is managed by npm. We don't care, okay? If you really want to care, you just have a look at the package.json and you discover what has been inserted as dependencies, okay? And let's have a look at the rest. Maybe it's better to have a look here on the slides. So there's a generic structure. I wrote typical for it because they changed it a little bit. I mean, they added 3 icons instead of 1 and so on. I mean, so, but these are just details. The important things are there. So there is a src directory, contains all the script, in particular contains main that we are not going to touch until at least we talk about the router. And then we have source app.jsx, which is actually the one I opened before, which is the place where you should develop your code and put your code, okay? And we will change code here today and test our code here. You can, of course, import whatever you want, other components, other libraries, and so on. And so what's the rest? Well, the rest is just icons, okay, convenient. I mean, React SVG, I don't know, is some logo and so on. Package.json, package lock, some configuration file and so on. index.html plus the public folder. Index.html is the template page for our web application. It's the one that is served by the internal web server that is already configured with Vite. Okay? It contains an element with ID root. Let's have a look. Just to have a look at how it works. Index. You see the body. The body is empty. Okay? Div ID root and script type module source main. Main contains get element by ID root, render, the stuff that we saw before, and render what? The components. Okay? These are components already defined by React. Okay? Actually, strict mode is already defined by React. App is in app.jsx. In app.jsx, we have a function. Okay? Doesn't take parameter. Here you could have props. Okay? But I mean, it should be passed by React. So I mean, there's no point in having these props here. And this component is just a single component that is present in this demo application. Okay? And of course, it does a lot of things. I mean, we are going to destroy everything, okay, and test something else, okay? But you see, it's basically HTML code. This is the JSX code, because you see it here, I think. You see count, it's count. You see the curly brackets with the JavaScript value and so on, okay? Return, and returns this HTML code, okay? That defines the user interface fragment that is in our application is the whole application. Okay, good. So we just experiment with some examples, okay? So here you see some code, and now we copy paste from here to the application, and we see the result, okay? So you see function up, that's the entry point, because you saw the file, right? The main app loads up, okay? The app component, and so app returns p, press here button, b button. That's a component defined by us, okay? That takes some props, and we will see how props work and so on, okay? But just to test everything works, just to copy paste and make sure everything works. How do we do this? I think I already have the files, because copy pasting from the slides is a bit painful, because there are new lines and stuff which always go wrong. I think example button, that's it, right? Copy and paste here. Okay, I think we can delete everything except the export up at the end. Yes. So leave the export up. Okay, and the rest is here. Okay, save. Don't forget to save and check what happened. No, it works, right? Yes. No errors in the console, so no message here. Why? Maybe I just resized the window. Yes. So you can stop with Control-C, and you can restart npm run dev. It doesn't really matter. Okay. So, often it automatically reloads, but sometimes it doesn't really work well if you change many files. So sometimes it's better to stop the web server and restart it. And basically, this npm run dev goes into the package JSON, look for the command to be run, and it runs this command that starts the web server. Okay. So the web server is again localhost 5173. And press here, ciao, that is hello in Italian, I think everybody knows. And you see the P, press here, button, ciao, okay? That's the content of the HTML, so the actual DOM, okay? That is being generated automatically by React through the virtual DOM. And we wrote something to be rendered as a virtual DOM here in the code, okay? Function up, return a fragment of user interface. So this JSX syntax that allows us to use the tags that are already available in HTML or that have been defined by us in the form of components. You see, P is already defined, but button is defined by us. Function button takes props. Props are basically the attributes. Okay, we'll come back to this in the second part of the lecture. If you write something different like lang n save, you will see the result hello instead of ciao. Okay, we modify the code. I know this is not so wonderful in the sense that if we modify the code, we can also modify what is written, right? We don't have to modify props. But this just shows that props, if you modify props, React takes care of reading the props in the component, so here in the button, and depending on the value of the button, it renders one fragment of user interface or another fragment, okay? And now this function is idempotent because what it does, what it returns is only defined by what is passed as props, okay? And it has no other side effects, so it doesn't do anything outside the, it doesn't set values or read values outside the function, okay? So that's a basic application, a very, very basic application in React. Okay, so we tested this stuff. App must return the JSX or the whole application, and indeed is what it does, P and so on. And if you have a basic HTML text, well, everything is fine. If you have components, components are rendered and substituted by the return value that is computed by React. Either button ciao or button hello, okay? So here you find button ciao or button hello. They can receive props. Lang comes JSX. We decided to call it lang. That's our choice. We could write language, whatever we want. We just need to know that the key, so the value of the attribute that we find here in the object props, has the same name as the one we defined here, okay? So we want to change it, want to make it language, okay? To make it work, you need to write language here, okay? Save, okay? Otherwise, it's undefined, and the code follows the undefined path. So either the first item or the second item in the if. But I mean, try not to not to write wrong code in the beginning when you're testing. Otherwise, it becomes difficult to understand. Okay, let's see other 4 examples. I think. So components in a separate file. We can move components out of the main file. Otherwise, we have a big app.jsx file, and that's not good, right? So import button from button.jsx, export default button. So what you learned about modules here applies entirely as it is. Okay, they are actually modules, no difference. Okay, so button.jsx, there should be button.jsx file ready to be used. Copy, paste in app. In src, remember here inside src, button, okay? Oh yeah, it uses other stuff. For later, okay, we'll see it as the last example, okay? No, we'll see it now, okay. So there should be an example, a simpler example. State button group props. No, okay, this one, props only. Okay. Save. So button JSX, that's the same code as before, right? App JSX, we remove button here, and we just import, right? Import button from button. Let's see if it works. Oops. Okay, always check the console. If something is wrong, either it's immediately rendered there if there is a syntax error and React has no idea what to render, or it's printed here if it's an error which is less critical. Okay, so you can import any element from other modules. Actually, a JavaScript. Okay, you're programming in JavaScript, so no difference from the usual stuff. Okay, so you can decide to have a default export, name the export, and so on. Okay. Okay, good. Just for the sake of examples, seeing examples, let's try a state, which is a bit nicer to see, okay? Even though we are going to talk about states on Thursday, let's try this code, and I will comment it briefly as well. So, example button state, so copy and paste it in button. Oh, but I need to export. So, okay, save. So there is the same button as before, but now we have this state, okay, use state. That's a function provided by React to create a state. We initialize it with a certain value. I think now we had language here, right? Language, yes, language. Okay, having a DI is nice at certain points, right? Button lang. Set button lang. Button lang is the value of the state, and set button lang is a function to do a modification. Okay, that can be used in an event handler. And event handler are easy to write because you attach a function to an attribute on the element where you want to handle the event. Okay, and in this case it's very simple what we want to do. So just have a function that does set button lang and or it or whatever. Okay, so it changes the state. Okay, save. Let's try. Okay, nothing has changed, right? Click, ciao, hello, ciao, hello. So if it's Italian, it goes to English and vice versa. Okay? But you can see the state as well. You need to go to button, and you see props, language, and that is what is passed from up in the code, okay? So language and this will not change, okay? Because the property passed here is always the same. What will change is the content of the state, button lang, okay? Which is here, state n. We cannot see the name of the variable because it's a long story that we will understand only at the end of talking about hooks. Anyway, you see that I click, you see the state IT, ciao, click, state, and hello, okay? And this happens through all the mechanisms that I told you before. So there is this virtual DOM in the memory of JavaScript created by React. You click, you change a state. This change of state triggers the call of all the function that depends on properties and states that have changed. In this case, just button. Button is called again. The return value is taken. So it becomes n. So this return value is taken, is put into the new virtual DOM. The difference is computed with the old virtual DOM, and the difference is applied in the actual DOM. And what is shown by the browser changes. Okay, that's the mechanism, which is quite long. It seems a very complicated way of doing a very simple thing, and of course, in this example, probably it is. Okay, but when you have a much more complex application with many states, many things that can change, data arriving from the server, and so on, this we simplify the way in which you handle the user interface. That's the purpose of React, of course. Okay. So adding Bootstrap. We learned the Bootstrap, right? So we want to use it. How do we use it? Well, actually, we need to load it. But the nice news about Bootstrap here is that we don't have to load it separately with the script tag, with the link, CSS, link, hash, and so on. We can simply import it. And Vite, so the environment we are using, is taking care of handling all the stuff. So basically packaging everything together and serving it to the client. Okay? That's good because, I mean, for Bootstrap, well, just CSS, so, I mean, in a certain sense, it's more or less simple. So let's do the import. So, not sure if we have it. Yes, we have it. Okay, import Bootstrap, and so app, in app, we import it. Don't remember that we need to install everything we import in React, okay? So just stop it. You see that this import doesn't work, okay? Why? Does the file exist? No, it doesn't exist because I didn't install Bootstrap, okay? Which for convenience it's also provided as an npm package, okay? Again, just for convenience, but it's actually something very convenient, right? So npm run dev. Let's see the result. The result is quite ugly, right? I mean, the button has to use the style of a Bootstrap style, right? To use the Bootstrap style, I think, do we have a slide on this? Yes. No, but this is React Bootstrap. Okay, we do it manually, don't worry. Class name, okay, it's not class, so you cannot use class. In JavaScript, you have to use class name. That's a limitation because class is a reserved keyword, okay? So the attribute has to be called class name, and by React, it will be interpreted as a class attribute, okay? I think button primary, right? But, oops, button primary, right? Okay, we change it. We changed. I'm not used to this this AI so much. Sometimes I press the wrong key, right? I think. Okay, I deleted something too much. Button primary. Right? Save. Stop, start. Okay. Don't be fooled by the fact that, sometimes it doesn't reload automatically. If you are convinced that it should work, stop and restart, okay? And, oh, no, it doesn't apply the style. Why? I have no idea. Why should never go, I mean, the class should be button, right? btn. Yes. It should work, right? No idea why it doesn't work. Let's debug a little bit. There should be about Bootstrap is loaded. You see here it's loaded. And then Bootstrap buttons, I think they should be. Class, yeah, prime. Let's see what the AI says. Ah, that was Italian, right? Yeah, no, that's the English one. So save it. Let's save it. Ah, you see? Okay. Okay, that's the, because I put it only on one version of the button, right? So, yeah, that's the Italian version, ciao, that is styled by Bootstrap, okay? And the English one is not, so you can see the difference, right? Okay, that's the basic style of the browser, very ugly, right? Last thing. Yes. See, it's so common, right? So you want to use a Bootstrap styles or another library style in React components. Somebody took care of the problem and decided to write a library, a package, named in this case React Bootstrap, that basically already creates components that have the Bootstrap style and sometimes also some behavior already ready to be used using attributes and so on. Okay? For instance, a button is one of them. And so if we install this React Bootstrap library, so stop, install React Bootstrap. Okay? So it's basically a package that provides, this time provides React components, not Bootstrap. Okay, just React components. And so you need to install Bootstrap as well. But in this case, you can import components as we imported here, our button, right? So I think we have Bootstrap exam, Bootstrap apps, right? So yeah. So in the button, we import the button. So we need to change the name to our button, okay? Otherwise they clash because they have the same name. My button, okay? A lot of fantasy as usual. And you see that the AI tells us, well, you should change the code in this way. Let's read it. The event handler is the same, the content is the same, button is B uppercase, which is actually what we imported. All React Bootstrap components are uppercase, by the way, as all React components. And yes, they changed the class name and so on in variant, because who designed the one who designed the React Bootstrap library decided not to use the class names, because class names are just for applying classes in terms of CSS classes to components. So it defined a new set of attributes to be used with their components. And you find them in the examples of the documentation of React Bootstrap. Okay? For instance, for this case, variant is the attribute that decides which type of button we want to have. Okay? There are different types of button in Bootstrap: primary, secondary, warning, alert, and something else. Basically, change the color. Okay? But for us, that's enough. So let's save it. We have my button now, so we need to export the my button. Save again. Going up, use my button, but import my button, right? Save. Okay? So let's start again. Unable to connect. I forgot to start the server. npm run dev. Again. Hello. Ciao. Okay, ciao has the style of Bootstrap, but now it's been achieved through a component, a React component, which has already been prepared for us. That's inside the React Bootstrap package. Okay? So in this case, we have call, container, row, and so on. So we have also components for doing layout and all this stuff. Okay? Yeah, that's basically what we saw. So just have a look at the React Bootstrap. I mean, just go on the internet, React Bootstrap, okay? And you will find all the documentation, components. There's plenty of components that you can use. Of course, the buttons that we saw before. You see the examples, primary, second, and so on. But you see also the layout, right? So you want to achieve the grid layout, you want to achieve the column layout, and I'm not sure where it is. Breakpoints are other stuff, not required for the exam. I cannot find it where it is. But for instance, for the tables, for the second lecture, I mean today, there is a component already ready to be used. Or for instance, for cards, or I wanted to show you something more useful. Alerts. People like alerts. Don't use the browser alerts. Never use the browser alerts. Why? Because they are not managed by React. Okay? We want React handling all the user interface. If you really cannot do anything without an alert, use this alert from React Bootstrap. I think that there should be a button to test the demo. I cannot find it now, but I mean, check it out. Not sure where you should press. Anyway, somewhere you should be able to press it and see the alert. Anyway, I wanted to show you, okay, the accordion. That should work. Like, you see the behavior? That's done automatically. You don't have to write a single line of code in JavaScript, in React, and so on. Okay? That's done automatically by the component that is ready to be used by you. Okay? Yeah, and there's plenty of other stuff like this. Okay? I'm not sure if the toast works because we're a bit unlucky. Yes, this is a toast. Yeah, but toggle toast. Okay. Here probably I think you should write a little bit more code in the sense that you need to attach a function. Okay, but that's for later. Not today, but next week's. Okay, but I mean the message is that plenty of components are ready to be used. So I mean I know that we started from a long story, right? We started from programming JavaScript, manipulating the DOM explicitly with JavaScript calls, create a node, append child, and so on. And then we say, okay, that's the problem of styling, write CSS, use Bootstrap, simplified CSS. There are already classes available. And now basically, remember the first slide, you throw everything away, okay? And we start using React, Bootstrap React, React Bootstrap. So components already ready and prepared for you. And for the rest, there is still Bootstrap when you need to apply some styles. And we will learn how to write simplified JavaScript for more complex applications with less code. Okay, that's the idea. There are a lot of things that we still need to care about. Okay, for instance, when you have arrays of items, how to render them. That's the topic for next, not next lecture, but next hour and a half. And then how to use JSX in the best way, how to use state, and so on and so on and so on. And we will arrive almost at the end of the course, because then we still have one problem, a very important problem, authentication. Okay, and we will spend a lot of time, quite a lot of time on authentication, because web applications are multi-user applications. Today, we are just, running a web server and accessing the application ourselves. So it looks like there's a server and a single client, but it's not like this. A generic web application has multiple clients, and we need to be able to handle multiple customers. This is absolutely required for the exam, okay? and one of the things that is very checked very carefully. Okay? So I think we can stop here if there are no questions and have a short break, the usual 10-15 minutes break. Okay? And then we will see other examples again in the next hour and a half. No questions, so we break here. Thank you.